start with 8254, which is known as Programmable Interval Timer as well as counter. It works both ways. It works like timer also, and it works like a counter also. All right. So this is a very small chip having very few number of pins, like it's having only 24 pins in its pin diagram. It's having very small block diagram. Okay, so I'll try to cover it as maximum in today's lecture. So let's see the block diagram first. No, sorry, pin diagram first. So you can see the pin diagram of this 8254. What we are having in this is we are having three independent 16-bit counters. The most important thing in the 8254 is it is having counters. And how many counters it is having? 3 counters. What is the size of these counters? The size of the counters are 16-bit. Okay, so what it is having is 3 16-bit counters. The purpose of them is to hold a value. Let me tell you what operation counters will be doing. So what we know about counters, they works like we do in the loops. We load a value, let's say 3 is the value I'm loading inside a counter. So counter is like, they work simply like a software loop. One loop, then decrement 3 minus 1, 2, then checkpoint. Is it equal to 0? Fine. If not, no, go back. If yes, exit. So it is like that. The counters operation is something like this. You will load a value inside the counter, and that counter will repeat the task for that number of times. This is what the initial objective of this is. So that kind of purpose can also be utilized in a different way. If I tell you about the application of this 8254, this can also be created like a real-time clock that you might have seen on the railway stations, those big LED lights showing you the time. At that places, if you want to know what is the main IC which is being used inside, so this is the IC that is being used mostly inside those timing displays 8254. It gives you the exact time calculation as your output. Fine. So it is utilized for real-time clock, and there are places in the past in the theaters, in the auditoriums, where we want to count the number of persons entering in a hall or arena or amphitheater or something. So these are generally connected on the entrance, just on the top of the entrance, a gate or a door, so that it can count the number of persons. So it is also having an application of event counting. So how many times something is passing in front of you, you can just connect a sensor and it will just keep counting the inputs of the sensors. How many times the sensor is giving input back to the 8254. So these are few applications of 8254. It is mostly related with the real time. Wherever you are having a real time or you want to count something, this is the main application of this 8254, and they are very versatile in the hardware market. Okay, so let's get back to the pin diagram, how it looks like. It is very simple. 24 pin DIP it is. Only 24 pins it is having. So let's start with the pin diagram. From pin number 1 to pin number 8, this is the data bus connection. The data bus of 8254 from pin number 1 to pin number 8. Fine. After that, there is this combination clock, out and gate. For this, I need to take you to the block diagram because this thing is coming from the block diagram. Okay, so let's see the block diagram of 8254 once. Let's see the block diagram of 8254 once. Okay, so like we did in 8255, you can compare this with the technical drawing ability or how to remember this for a long time. This is very simple. 3 block this side, 3 block this side. All right, 3 block this side, 3 block this side. Right side counter 0, counter 1, counter 2, because there are three blocks here, three counters we are having. That's it. Again, three counters are having three inputs. Fine. Two inputs are clock and gate, and one input from control word register. You can see in the arrow form. One input is clock input, other is gate input, other is this clock control word register input. Fine. Three counters on the right, three inputs to every counter. You can see. Fine. But what we are seeing in the pin diagram, we will not see this control word input in the pin diagram. What you will see is clock 0, 0 for counter 0, gate 0, and out 0. Fine, and I'll tell you the operation of these three pins also. So what happens in these when we have a counter? The counter, one input is called clock. Clock is an input that will always be connected. Okay, so let's have what and how counters are going to be. So this is a counter having one input like clock, other input is your gate, and other one is out pulse which is coming out of it. Fine. So clock is what? Clock is a continuous train of pulses which will be connected all the time to assist the operation of this digital circuit. So this is one thing which will always be connected to a digital circuit. The clock is mandatory. You can't just avoid that. Fine. But next is your gate. Gate is what? Gate is one type of tri-state input, you can say, because until and unless gate is 0, you are providing a low pulse towards gate. This gate will not allow an output to pass. You will not receive any output across this out terminal until and unless this gate is 0. Fine. The moment you turn it to 1, you provide a 1 pulse or the high pulse to the gate, you will start getting the output from the out terminal. Alright, so gate, you can also say this is an enable pin, or it is a control pin, or it is just modulator pin, whatever you want to say. Gate is the tri-state input which is controlling the outputs. Okay, and that phenomena was earlier in a circuit which was called thyristor. We used to call them thyristor. Yes, this gate concept comes from the family which was earlier known as the thyristor. Yes. So let's get back to the pin diagram again. So what we can see here, whenever we see clock, out and gate, that means there is a counter. And which counter? 0 associated with them. So that means this is the place where your counter 0 is in pin diagram. Counter 0. Okay. Clock 1, gate 1, out 1. This is your counter 1. Clock 2, out 2, gate 2. This is your counter 2. Fine, so this is how your counters are visible in your pin diagram. Clock 0, clock 1, clock 2. Sorry, counter 1, counter 0, counter 1, 13, 14, 15, 16, 17, 18 is your counter 2. A1, A0, this is called selection lines. Selection lines. Alright, now what they are giving us again, like 8 to 5, 5, there will be a pattern of 0, 0, 0, 1, 1, 0 and 1, 1, by which we can select the counter 1, counter 2, counter 3, counter 2 and the control word register. And the control word register. So this is for selection of various counters and control word register. A1, A0. CS with a minus sign, this is for this active low. This is just a bar, WR bar, fine. So CS bar stands for chip select. So since it is active low signal, so in order to select it to 5-4, the CS bar must be kept at 0. Okay, so in order to connect or in order to uh, select 8254, the CS bar must be 0 always. Fine. Read and write, they are the control signals that will be working with microprocessor to read or write. Read or write. Pin number 24 is the power supply VCC plus 5 volt, and another one is your ground for circuit completion, and that completes your pin diagram. So you can see in the pin diagram how many pins we are having. 24 out of 24, 8 for data bus and 3339 for counters. And what we are left with? We are left with RD 67 out of 67. VCC ground, A1 A naught, CS are read write. These are the Thus, this is the simplest pin diagram you will see in your syllabus. Alright, is that clear? So let's get back to the block diagram once. So you can see in the block diagram the 3 counters on the right side connected with the required input outputs, 3 on the left. One is data bus buffer, one is read write logic, other one is the control word register. All right, so this is the simplest block diagram also. So let me show you what selection lines will be giving us. So this A1 A naught, when they both are 0, counter 0 will be selected. When they are 0 1, counter 1 will be selected. 1 0, counter 2 will be selected. 1 1, control word register will be selected. Okay, but in order with CS bar, the CS bar must be 0 all the time. We are working with 8254. All right, so this is the function of this selection lines. So after the selection lines, the main thing we are having is the heart of an interfacing IC, which is called the control register or control word register, which gives us the programming for 8254. Fine. So if you want to note down the most important thing about 8254 is its operating modes. 8254 is having 6 modes, and they are the most important in the case of 8254. These 6 modes are having different kind of operations, connections. All right, so this is the most important thing that we'll be having. Okay then, so first we need to understand about the control word register format. So again, it is simple. It is 8-bit format of control word register, control register. We will be putting ones and zeros like we did in 8255, and this time it is very simple again. Fine. So this is the format of your control word register, and before selecting the control register, there will be some default selection parameters like what will be at selection lines A1 and A0. 1 1 will be there because we are going to select the control word. CS bar chip select, it has to be 0 always. If you are working with 8254, read should be disabled. Yes, it will be, it is, because 1. Writing should be enabled because we are going to write something inside the control word register. Now check out the format again. This is an 8-bit format. So let's start from D7 and D6. D7 and D6 are the SC1 and SC0. This SC stands for selection of counter. So what we are having three counters. So which one you are going to work with? You are going to work with C0, counter 0, counter 1, counter 2, that's it. Alright, so if I say start using counter 1 to event counting. So this is what I'm giving you as a configuration. So if you want to select counter 1, what configuration you will put in D7 and D6 is 0 and 1. Alright, counter 2, 1, 0 to the respective problem will give you what to put inside the D7 and D6. This is the pattern: 0 0 for counter 0, 0 1 for counter 1, 1 0 for counter 2, and there is one more command we call read back command. Fine, if you want to select read back command, you can provide 1 1 in the D7 and D6. Okay, that is simply for selection of counter or RBC, read back command. Next is D5 and D4, and they are very important. D5 and D4, they are very important. Just focus on them. They are seriously very important because they are confusing. There are few pins that will confuse you. The moment I'll be asking you to design something, you will be asking me, sir, what to put in D5 and D4. Okay, so focus in that. Focus on D4 and D5. This is RW1 and RW0. So let's see what is inside this. R stands for read and W stands for write. RW1 and RW0. What happens when they both are 0? This is not to be used in the programming. This is only showing the counters have been latched, connected. Next we have RW1, RW0, RW, sorry, RW1 0, RW0 1, 0 1. So in this case, what it is saying is read, write, least significant byte only. Now from where this least significant byte came, see here. The size of the counters is of 16 bit. But if the count value which we are inserting inside is not 16 bit, the value is not 16 bit, then what? Then what? Then we are going to waste some material or some bits. So what is going to happen is the flexibility is you can use the counter in 8-bit modes, 8-bit LSB, then 8-bit MSB, 8-bit LSB and 8-bit MSB. So what they are trying to tell you, when you select 0 1 in RW1 and RW0, read or write LSB only. LSB means 8 LSB bits which are on the right side. Okay, so that means we can save the 8 MSB, 8-bit MSB. Okay, that we can select in the next one. 1 0, that means read write MSB only. So this is taking this section. Fine, so we utilize the 16-bit in the pieces of 8 bits. Okay, so when you select, when you put 0 1 in RW1 RW0, this section will be selected, and when you put 1 0, this section will be selected. Okay, next is when the both are 1, RW1 is 1 and RW0 it is also 1. So what it says read write LSB byte first, then MSB. So what we are trying to understand from this, we have 8-bit LSB and within 8-bit MSB. What it is saying, first it will read the LSB, then it will read the MSB. That means what, they are combining both, and this time the size of the register is of 16 bits. The size of the value is of 16 bit, full-fledged 16 bit. So this is an indicator whenever we are calculating the value of count. If the count value is of 8 bit, you can use any one, 0 1 or 1 0. You can use any one, 0 1 or 1 0. But in case if the count value is coming out of 16 bit, the count value, if it is coming out of 16 bit, then what's going to happen, you will be always selecting 1 1 in RW1 and RW0. It is mandatory because this is how it will be selected. Alright, is that clear?
Yes, sir.
Okay, then next is D3, D2, D1. They are basically for the selection of modes, and there are 6 modes in 8254, mode 0, 1, 2, 3, 4, 5. So you just need to place the respective bit. Suppose I say select mode 0. So move for mode 0, just place 0, 0, 0 inside, and the mode 0 will be selected. Suppose I'm asking you to select mode 5, you know what to select, what to place inside 1, 0, 1, 1, 0, 1. So this is just for selection of the particular mode which we are going to use in 825. Next is D0. D0 is again particularly very important, but I'll try to make it simple for you. If D0 is equal to 0, that means your operation will be in the binary. The counter will be in the binary. Binary means what? Everything will be written in the form of 0, 1, 0, 1, 0, 1. The counter will be loading its value in the form of 0, 1, 0, 1. So that will be confusing you sometimes, because mostly we are using the BCD. Mostly we are using BCD everywhere. So just keep in mind one thing, just keep it 1. Always use BCD. Binary use ही नहीं करना है, just keep it 1 always, so that there will be a symmetry in all the coding patterns. It is not like in 8254 you have to put D0 is equal to 0 because of binary. No, just keep it BCD everywhere. Just keep it 1 fixed, that's it, finish. So this is the control word register of 8254. Is that clear? Any doubt in this? It control word register, block diagram, pin diagram. Anyone?